You're all good.
You can sit wherever you like. It might be better.
Little.
All right, I guess we should get started. There seems to be a little bit of confusion about the rooms. This is the Padang room. This is the IRTF open meeting. If you're looking for the Collier room, you should be next door. Okay, so this is the IRTF open meeting. My name is Colin Perkins. I'm the IRTF chair. There should be blue sheets circulating shortly. Please make sure you sign in. A reminder that the usual IRTF intellectual property disclosure rules apply to this meeting. As with the IETF sessions, if you know of IPR related to the discussion, when you're making a contribution, you need to disclose that. In addition, I'd like to remind you that this meeting will be being recorded, and the recording will be made public, and that we have a code of conduct, and please work respectfully with others when participating in the IRTF. Also, I'd like to remind you that this is an IRTF, an Internet Research Task Force session. And a reminder that the IRTF is focused on longer-term research issues, and we'll discuss more of this later in the session. But unlike the IETF sessions, which are happening this week, this is a research group. It is not a standards development organization. We're doing research here rather than standards. And if you're not familiar with the difference between the IRTF and the IETF, then RFC 7418 is a really nice primer for new participants in the IRTF who have been used to the IETF process. We have a number of ways in which you could keep yourself informed about the IRTF. We've got the irtf.org webpage, which lists information about all the research groups, about all the other activities we do here. We have Facebook and Twitter accounts. The Twitter account is perhaps more active than the Facebook page, but we have them, and feel free to follow us on social media if that's your thing. We also have mailing lists for those who like things more old school. And please subscribe to the lists. So the IRTF is comprised of a number of research groups. Right? We have 14 research groups in the IRTF, of which 13 of them are meeting this week. The DIN-RG group is not meeting, the Decentralized Infrastructure group, but all the rest are meeting. Of these, 2 of them, the Computation in the Network group and the Quantum Internet group, are proposed research groups. New groups get a year to act as if they are a research group, and then they go for a review, and we decide if they should be made permanent full research groups. The Computation in the Network group will be having that review this week. The Quantum Internet group will be doing that at the next meeting. All the rest are full research groups. The majority of them have still to meet, so look out for them on the agenda, and please do consider participating. In addition to the research groups, we run 2 other activities in the IRTF. Those of you who were at the meeting in Montreal earlier in the year would have seen the Applied Networking Research Workshop for 2019 running in parallel with the meeting in Montreal. I'm pleased to announce that the 2020 Applied Networking Research Workshop will co-locate with the IETF in Madrid next summer. That workshop will be chaired by Miria and Roland, who many of you will know. Look out for the call for papers for that in the next couple of weeks. I expect the paper submission deadline will be in the sort of March-April timeframe, and the proceedings will be published in the ACM Digital Library. This is all done in conjunction with ACM SIGCOMM. The other activity we have is the Applied Networking Research Prize. This is a prize awarded for recent results in applied networking research, which may be relevant to transitioning into internet products, related standards, and the IRTF and the IETF. We've got one ANRP prize-winning talk, which will be happening just after I finish these introductory remarks by Wei-Ting Cheng, who'll be talking about off-path TCP exploits and how wireless routers can jeopardize your secrets. We also have the nominations for the 2020 Applied Networking Research Prizes, which are now open. If you go to the irtf.org/ANRP website, if you've read any good papers on applied networking research, anything which you think would be deserving of a prize, to bring the author to the IRTF and the IETF for a week, then please consider nominating that work. Right? The deadline for nominations is at the end of this week. We're always looking for good nominations, good work to potentially award the prize to. We typically award 2 prizes for each of the IETF meetings, so we're looking for 6 good papers to make the awards to. We had hoped to have two prize-winning talks today. The other speaker, the other awardee, had family issues, which meant that she couldn't attend this meeting, so we'll be postponing that talk, and we'll be doing it at one of the later meetings instead. So that's about all I have to say. The agenda for today, the first thing we have up is Wei Tang with his ANRP prize-winning talk, as I say, on off-path TCP exploits. Following that, we've got a brief update on the computation in the network research group, which, as I say, is finishing its third meeting and will be up for transitioning from proposed research group to full research group after this week. And then we've got some discussion. We've got a little bit of discussion from Melinda will be leading, talking about the relation between the IRTF and the IETF. Aaron and Laurent will be leading some discussion about moving work from the research world into the standards world. I'll be finishing up with some discussion about how the IETF can help, how the IRTF, if you excuse the typo there, can help academia and vice versa. So with that, I guess we should move on to the prize-winning talk. Wei Tang. Come on up.
Okay. Good afternoon. Thanks for the introduction and thank you for coming for my talk. Oh, okay, sure. Is that better? Okay. So today I'm going to share a new side channel we discovered in all generations of wireless technology and how we can exploit it to perform off-path TCP injection attacks. This is basically a cross-layer attack in which a design choice of wireless protocol can actually compromise the security at application layer. So what is the off-path TCP injection attack? Here's the threat model we used in our work. For now, the router is not involved in this threat model, but I will get into that later. Typically, given two hosts, one client and one target server, malware is able to inject spoof data into the victim connection between the client and the server. The attack is performed in the following steps. First, malware can lure the victim into visiting the malicious website, for example, via phishing email. And then when the victim clicks on the link given in the phishing email and visit the malicious website, a JavaScript will run on the client machine, which can initiate two connections, one to the target server and the other one to the off-path attacker. Since these two connections are under our control, we can send arbitrary numbers of requests to the target server so that the connection between the client and the server can be kept alive for a long time, as long as we keep sending requests to the server. As opposed to man-in-the-middle attacks, where the attacker can intercept the response and tamper the content, malware is completely off-path and cannot eavesdrop any of this traffic. Malware, however, can send spoofed packets with server's IP address to pretend to be the server. Of course, the client will validate every incoming packet based on some secret shared between the client and the server. The secret is created when the connection is established. Because of the secret, it's really difficult for the attacker, for the off-path attacker, to send spoof packets with the correct secret if we just do random guess. Therefore, the JavaScript running on the client machine is also for the purpose of sending some feedback, informing the attacker whether his guessing is correct or not. Since the JavaScript has no privilege, it cannot peer into the victim connection and steal the secret. Instead, we rely on some side channel to infer the behaviors of how the client responds to those spoofed packets. And then based on the feedbacks, the attacker can guess multiple runs and finally figure out what's the correct secret. You may wonder what's the impact of this thread model, because even though we can inject spoof data into the victim connection, the whole procedure is performed on the malicious website, and the attacker can already control the whole page. Why would we bother to do this? Well, the trick here is that once the spoof data is accepted by the client, it will be cached in the browser for a long time. So you can imagine that next time when the victim tries to access the same server, the browser will actually reload this injected page rather than sending a new request to the server. And even worse, if the user does not clear the cache manually, it can be cached in your browser for years. Here, supposed to be a video demo, but unfortunately we cannot do that. So I just took some snapshots to give you some flavor of how it looks like. As I mentioned earlier, when the victim tries to access the malicious website, there are actually two connections underneath. One connects to the target server. In this case, it's the CNN News website. And the other one connects to the off-path attacker launching the real attack. Once the attack succeeds, the injected page will be cached in the browser. And when the user tries to access the homepage of CNN News, he or she will actually see this page showing up. As we can see, there is an injected login component at the top. This is one version of the attack we performed for Windows. There is actually another version for Mac OS. You can find these two videos through the link given in our paper. So what's the secret I'm talking about? In order to successfully inject spoof data into the victim connection, we need to know how TCP stack validates an incoming packet. Here's the simplified TCP specification. The secret I'm talking about is actually the 3 tuple, including port number, sequence number, and acknowledgement number. So let's take a close look at the sequence number check. As we can see here, when the packet contains an out-of-window sequence number, the client will actually send a response back to the server. In the other case where the sequence number is in window, but the acknowledgement number is out of window, the packet will be silently dropped. So we can see here, there is the client will actually behave differently depending on whether the sequence number is in window or not, right? I actually have a question about this, and I got this question a lot, but I don't have a perfect answer for this. So basically the question is that why the client should send a response back to the packet even if the packet contains an out-of-window sequence number. Does anyone in this room know the answer or any reasoning for this? Because it sounds weird if you know that the packet is broken in terms of regarding the sequence number, why we should send a response back, right? Yeah, that's a question we can discuss later. Let's move on. So there are actually several side channels against the TCP connections. I'm not going to dig into the details, but I just want to summarize. The first 2 side channels have been fixed already. The third one requires a malware running on the client machine to monitor the system. In our work, we discovered a new side channel that is inherent in all generations of wireless technology. And the off-path attack we present in our work only requires a JavaScript running on the client machine. And all 3 major operating systems are affected by the attack. It's also worth noting that our attack is the only working one without any mitigation in place, and it's practically infeasible to fix it. So from a high-level view of the side channel attacks against TCP connection that are discovered in prior work, all of them manifest themselves through the following control flow block. There are actually 2 essential building blocks. First, anytime you have a side channel, there must be some global resource shared between the attacker and victim. In the context of TCP side channels, depending on whether the sequence number is in window or not, the shared state may change accordingly. Secondly, and most importantly, the shared state change must be observable to the attacker. So what's the shared resource we discover in a router? Well, the insight is that the half-duplex nature of wireless creates a shared resource between uplink and downlink traffic. Half-duplex is in contrast to full-duplex. Full-duplex means that both uplink and downlink traffic can transmit at the same time, while half-duplex only allows one direction to transmit at a time. For wireless networks, it makes perfect sense to use half-duplex because if both ends try to transmit at the same frequency and at the same time, it's likely to cause interference, backoff, and then retransmission. Since half-duplex is a fundamental design choice of wireless protocol, it's really difficult to change. Let's consider the following two scenarios in wireless. Let's assume that the client has established two connections, one to the target server and the other one to the outpass attacker. In this case, the outpass attacker can send both legitimate and spoof packets to the client. Because wireless is half-duplex, when both uplink and downlink traffic are transmitting at the same time, it's likely to cause interference, which enforces either or both ends to back off and then retransmit. Suppose the client gets the chance to transmit, then the spoofed packet has to wait to be sent later. So does the third packet. As we can see here, the round-trip time of the post-probe query now is prolonged due to this particular spoofed packet. Let's consider a similar scenario. Compared to the previous one, it's almost the same, except that now the spoofed packet can trigger a response. Recall that when the packet contains an out-of-window sequence number, the client should send a response back, right? But the issue here is that the packet is sent back to the server. So how does the attacker can see the difference? Well, because of this additional response triggered by the spoofed packet, the packet, now the post-probe query, now experience more contention, increasing its round-trip time. Let's put them together. As we can see, there is a timing difference of the round-trip times for the post-probe query in these two scenarios. Therefore, based on the round-trip times, the attacker can determine whether the spoofed packet has triggered a response or not, which in turn tells whether the spoofed packet contains a correct sequence number or not. However, you may wonder that the timing difference resulted from this additional response is too small to be measurable. Well, that's true. But what if we can amplify the signal? So in this figure, we also illustrate the amplifiable nature of the side channel. In this case, the attacker can send two probing spoofed packets to the client, causing more contention, which delays the third post-probe query even further, which means the more probing packets we send, the more contention we experience, and therefore we can observe larger round-trip times. I also want to mention that this is not exactly what happens in reality, because reality is more complex than this, but I hope it can offer a concrete example to show the timing difference. So far, we only conceptually discussed the timing side channel and its effect. Now I want to show some empirical test results to understand the real-world implication. We created a total of 16 different setups to make sure that the timing side channel exists in various products. We used 4 different wireless routers and 2 different machines of as the client, we also vary the frequency of each routers. So follow the same probing strategy I mentioned earlier. We measure the round-trip times of the post-probe query with 100 runs. We picked 3 representative test results here. As we can see, the timing difference is clear and measurable. On average, it's about 2 milliseconds. And also, the timing difference grows as we increment the number of probing packets we send per test. We also measure the round-trip times at 2 different locations, where the attacker is far away from the victim with round-trip times over 20 milliseconds. Although there is more overlapping between those boxes, the timing difference is still clearly present and measurable. So back to the TCP outpath attack, where we want to infer the secret. Let's start with the port number inference. Since the client will behave differently depending on whether the port number is correct or not, the attacker can actually send multiple spoofed probing packets with a guessed source port number to the client, and then determine whether his guessing is correct or not by simply exploiting the timing side channel. Now that we know the port number, we can further infer the sequence number. Compared to the port number inference, it's almost the same. We can still apply the guess then check scheme to infer the sequence number. However, the issue here is that it's unclear whether all the operating systems will behave the same as we illustrated here. So we surveyed the latest Linux and the Mac OS by inspecting their kernel source code and developed a test program to measure the behaviors of Windows. This table shows the behaviors of different operating systems when processing 10 identical packets. As we can see here, the 3 operating systems behave consistently on sequence number check, which means that we can always apply the guess and check scheme to infer the sequence number. There's one interesting fact about the behaviors of Windows. I didn't show the number in this table. You can find the complete table in our paper. So the fact is that we found that so normally in the RFC draft, it says that the client should send a response back when the packet contains an out of Windows sequence number, right? But I'm sorry. So in the RFC draft, it says that we should accept any sequence number in the window, right? But we found that in Windows, if the connection is idle, then it only accepts the sequence number that exactly equal to the next expected sequence number. And this behavior is never specified in any RFC standards. So I don't know why Windows have implemented in this way. So if anyone from Microsoft knowing the answer for this, I will appreciate the answer. Okay, let's continue. The implementation for acknowledgement number check actually varies significantly from one OS to another. So we propose customized strategies for each operating system by exploiting the HTTP specification and the behaviors of browsers. Remember that our ultimate goal is to perform off-path TCP injection attacks. We don't actually need to know the exact ACK number to perform the attack. Therefore, we can just brute force every possible ACK number. And even though we can still exploit the timing side channel to infer the ACK number, the brute forcing strategy is more efficient, only taking a couple of seconds as there is no waiting for check. So we implemented a complete attack for each operating system. The test results are shown in the up table regarding the success rate and average time cost. We also, to further demonstrate that this attack is practical, we also report the result under a remote attacker scenario, where the attacker is far away from the victim with round-trip times over 20 milliseconds. So how serious is the timing side channel? After we discovered this issue, we reached out to discuss this vulnerability with IEEE 2.11 working group. But unfortunately, we all agreed that this is almost impossible to be fixed at physical and MAC layers. That being said, we still need to discuss some possible defenses and mitigations. One straightforward idea is to make wireless photoplex. Although research has been done on this area, we are still facing some real-world challenges which need to be carefully addressed. And it's unclear when the technology will be widely deployed in practice. Since our attack also exploit the TCP specification, making TCP stack behave consistently regardless of the sequence and acknowledgement number would be a good defense. One possible strategy to consider is to limit responses for incoming packets with out-of-window sequence number, so that the attacker can no longer amplify the signal by simply sending multiple spoofed probing packets. Lastly, in application layer, using HTTPS instead of HTTP can prevent the attack, even though it does not eliminate the root cause of the side channel. And I also want to emphasize that deploying HTTPS is not enough if HTTP strict transport security is absent. One representative example is the CNN News website I showed earlier in the demo. You can see that CNN News website does use HTTPS, but we can still make the attack succeed, right? The theme here is that when the user tries to access the homepage of CNN News website, the initial request was submitted over HTTP, and then it's the server that subsequently redirects the browser to its HTTPS set. Therefore, the attacker can simply inject a spoofed page, inject a fake page for the initial request. So my point here is that even though you have deployed HTTPS, if you do not enforce it, then it's useless. To conclude, we found a new timing side channel that is inherent in all generations of wireless technology, and we show that the timing side channel is reliable and amplifiable, and it's almost impossible to fix it without substantial change to the wireless specification. We also show that the timing side channel affects Windows, Mac OS, and Linux by studying their TCP stack implementation and conducting real-world attacks against them. We also stressed some possible defenses to alleviate this issue. The source code of the attack is publicly available online, so if you are interested, you should check it out. That's all for my presentation. Thanks for your attention. I'm happy to take any questions.
Okay. First of all, thank you very much. So,
this is Daniel Kahn-Gilmore from the ACLU. Thank you for this work. This is really great stuff, and it's a good reminder to all of us that timing side channels can be stepping stones towards other problems.
Yeah.
So I really appreciate the way that you've connected all the dots here and shown that this can be done. I was curious about your proposed mitigations, whether you've had a chance to test any of them in the same environments that you tested the exploit itself. So in particular, I'm thinking about the mitigations that can be done at the TCP layer itself. Right, the middle mitigation that you described there. If you had a chance to test like modifying the kernel or something like that to see whether it would affect the results that you got for the other attack.
Yeah, that's a good question. Actually, so if you look at the source code for Linux kernel, it actually have implement some mechanism like this to rate limit the responses for incoming packets. But we found that it's actually only rate limit for the incoming packets that has no payload. So I'm not sure why they're doing this, but so you can see that you can actually bypass this check. You just need to add one byte payload to the packet, and then it can it doesn't check the limit for the responses. So that's another question I also want to ask: why Linux kernel implement things like this. Yeah, there are a lot of discrepancy about all the implementation of Windows, macOS, and they seem to have their own implementation rather than stick to the standards. Yeah.
Allison Mankin, Salesforce. I really like this, and I also like the questions you were asking about why TCP is the way it is.
Yeah.
It's a very old protocol, but I think those would be very good discussions to have in a TCP working group, as well as the mitigations you've talked about, and also check on whether the new transport protocols are, making some of the. I think there might be less mistake being made now. But I had a quick question about your evaluation where you talk about the average time cost with slide 35. I was wondering what that meant. What does average time cost mean? Is that for 10 successes to get through in that amount of time?
Yeah, we launched the attack 10 times, and then we calculate average time for all 10 attack.
For all 10, okay. Because I wondered if connections are typically short, which many of them are too short, is it much harder to make this attack?
Yeah, that's actually it's feasible if you. I'm sorry. So I talked about this earlier. So these two connections are created by the JavaScript, which is under our control, right? So we can send arbitrary numbers of requests to the server so that the connection between the client and the server will be kept alive for a long time. As long as you keep sending requests, then the connection will be alive.
So the attacker can keep the connection
Yes.
up a long time. Okay, I hadn't picked that up. Thank you.
Yeah, thank you.
So I had a question. To what extent is this specific to Wi-Fi? Do you know if other wireless networks have similar issues?
So as I mentioned earlier, this is a fundamental design choice of wireless protocol. So and it of course make perfect sense to use half duplex. There's nothing wrong with half duplex, and the wireless has to deal with it. So we discussed this issue with the IEEE the 11 working group, and although they acknowledge this vulnerability, but we can do nothing to it.
Do you know if other wireless protocols have similar behavior? Did you look into that?
No.
Okay. All right. Any more?
Sorry, Chris Seal, just to extend that point, even though you don't know about it, presumably it would apply to any system where the last link is half duplex.
I'm sorry, could you repeat that?
Presumably, the same attack would apply to any system where the last link is half duplex,
yes.
even if it's not Wi-Fi.
Yeah, conceptually it is, but I didn't find anything using half duplex.
Thank you.
Mm-hmm.
Christian Wittmer.
Mm-hmm.
Have you considered mitigation such as using randomized delays in routers, and would they mitigate this kind of attacks?
Yeah, that's a typical mitigation, but you need to think about the implication, because the delay can cause, I guess, if it will slow down the whole network, then it will be another problem, right? So I'm not sure. Yeah, of course, you can delay, you can add more randomization here, there, but I'm not sure how we can implement it without minimal cost.
Okay. Are there any more questions? No? Okay, well, let's thank the speaker again.
Thank you.
All right, thank you. Next up is Marie-Jose. So while Marie-Jose is coming up, just a reminder that okay, come up. Just a reminder that nominations for the ANIP are open until the end of the week. So if you've read any good applied networking research papers, please go to the website and nominate them for the prize for next year.
Good afternoon, everyone. I'm Marie. I'm presenting in the name of our three co-chairs, Jeffrey, Eve, and I. And we're COIN, Computing in a Network. And before I start, for the IAB people who heard us this morning, this is going to be old stuff. But at the same time, I would like to thank you for all your comments this morning and to have actually highlighted new things that we should do in our group. It's not good enough?
You need to step nearer.
Again? Oh my God. Okay. So again, thanks AAB for hosting us and for the comments. So anyway, who are we? We're the people who want to put computing in the network or network in the computers, essentially looking at the melding of computing, networking, and storage as things go forward. And so we want to foster research in computing in the network. We want to improve the performance for the networks themselves and for the application, especially the emerging applications in machine learning, in industrial networks, and in autonomous systems. Our focus is architectures. I'm actually an architect, so I'm interested in that. Protocols, we have a lot of people in our group who like developing protocols. And also, because we also have the link to industrial R&D in the group, a lot of people are looking at real-world use cases, applications, and a lot of work in progress. We are a research group. We are not producing products. We're not even looking at doing products, but we're looking at new ways of using products, new ways of doing research with them, and even fundamental ways of changing maybe the way that we look at how, when we move information from place to another, what can we do to that information to make the whole thing work better? So how did we get there? There was some active networking in the 90s, which was more or less successful, but got people thinking that when packets go through the network, maybe there's some functions that can actually that can go with them. There was work, I would say, in the past maybe 5 years in data centers and especially orchestration of data center elements with the famous Paxos protocol. And I have to keep to this. I have the impression it's hitting me. There was a development by Barefoot Networks, amongst others, of the Tofino switches and who are programmable with the P4 language. Barefoot was purchased by Intel, which gave the whole thing a new way, maybe of looking at this computer architecture. Edge computing, for a lot of us, was mainly our careers. It had a lot of heritage from what people did in information-centric networking, name function networking, distributed network. There's actually another group, a research group in distributed networking that we plan really to collaborate with. A lot of our collaborators are working and worked on something that's called compute-first networking, which actually had two very successful workshops even before that we were even thought about as a potential research group. I talked about the embedded AI and ML. And also, if you think about it, up to now, a lot of people were thinking of applications. There were edge applications, there were cloud applications, maybe more and more just cloud. And there's a lot of applications that are poorly served if you only do cloud in terms of delays, in terms of intermittent connectivity, and a lot of things that maybe you want to do in between the two edges. So our history, we first met in Montreal, close now 18 months ago. It's not Infocom, it's SIGCOM. We had a lot of meetings there. We met people at Usenix this year. We met in Bangkok, we met in Prague, we met in Montreal during the summer. We're meeting here. We had 2 web-based interims, and we had 2 hackathons on P4 and data filtering in Montreal, and actually over that weekend. We're meeting this week on Friday, so please come. We're very lucky that we have a bunch of collaborators around the world. I was proud this week that we had also people from Singapore who collaborated to the hackathon and people from South America. So I think it was great that we were basically having people from everywhere. And so we have a really good mix of computer scientists, application developers, implementers, and people in industry. So it creates really a great way of discussing about where this is going. This is our work matrix. This idea that there's the cloud, there's the edge, there's everything in between, and how can we distribute the computation inside the network to essentially make things better. And to make things better, it's not a single thing, and it's not a single set of requirements, and it's not a single set of performance indicators. It actually depends on what the application and what the service needs. I don't have a lot of time, so I'm going to go fast over this, but this is all part of the discussions that we've been having for the past year. Where do we want to put these things? Obviously, not all boxes will perform network-related functions. There was actually a comment this morning about the fact that there's encrypted transports, and some of these things will not be compatible. What does it mean to do packet processing? To which level do we want to act on the packets? Do we just want to filter them so we can do something once the information filter with the residual error, which actually the residual packets, which would be something that is very much related to AI. Maybe we just don't want just to do compute, but also storage. I said if we do packet filtering, we may want to store these things. Where do we want to store these things? How do we deal with discovering where they could be stored? How do we deal with the security of that data, the privacy? So it's all part of that. Obviously, if I'm a developer, I don't want to specify where my computing is, but I may want to know how there's a discovery mechanism to allow me to find where this computing and this caching, if necessary, will be done in the best way. And obviously, more and more in big data applications, there's an awful lot of data at the edge, and we may want to do some computing to reduce this information and manage this data implosion. I come from Canada. In the northern regions of Canada, there is no broadband. And even if we want to have some big data applications there for monitoring the environment, for example, at one point we need to use a satellite to go up, and we may want to do some local processing before we do that. Our objectives is to systematically look at these different instantiations. We had comments from the beginning, and people who are here will recognize themselves. We're saying, well, are there any common principles? Are there common abstractions? Are there ways that we could do that in common? Or this will be completely a dislocated type of set of things that really don't work together? I think we find this may not be completely true, but there are common things. We're thinking of common data layers right now, and at least common computing architectures. We want to know what are the best practices. We want, again, to look at if there are non-forwarding functions. Obviously, not all nodes are forwarding, and not all nodes will be computing. And actually, what are the incentives to add this stuff in the network so that new services and implementers know that it exists? What's the commonality? I said we looked at it. So we want to select a programming paradigm. We want to marshal the resources. Obviously, we'll need to meet requirements. Constraint and policies. I've been working a lot in IoT and sensor networks recently, and there's a lot of constraints there. We want to be adapt to changing condition, leverage telemetry. And again, this was very much highlighted this morning, these ideas of the security, the privacy, and the trust guarantees. We have to be able to trust the elements that do the computing. We've been very lucky. We've been there for 1 year, and we have tons of people who contributed drafts to the group. And it covers, if you look at this except security, which somebody again highlighted this morning, all these drafts cover a lot of what we're interested in, augmented reality, data discovery, managed networks, app centers, industrial use cases, which is also one of my big thing, requirements, which is essential, and the transport issues. How are things when you look at end-to-end with encryption or even end-to-end principles and you want to start syncing computing element in between? How do you deal with that? And that's actually a big question that we have. So I would like you to join us Friday. And I think we're all very passionate about this. We think there's really cool stuff that we can do, and we hope you can join us in our soundbox. Thank you very much.
Thank you, Marie-José. Does anyone have any questions on this? Any questions or comments?
Either I was great and you guys are completely stunned, or I was terrible and you're all asleep. Thank you anyway. Thank you.
Thank you. So there's some really interesting work in the COIN group, so please do consider joining them on Friday. I'm assuming you're all still here on Friday. Okay. All right. So what we'd like to do for the rest of this meeting is spend a little bit of time thinking about the relationship between the IRTF and the IETF and discussing some of the ways in which the two organizations can interact and move work between the two organizations and so on. I think we have Melinda first. Do you want to say a little bit about the relationship between the two? I don't have any slides, is that right? Okay. And we try, we'd like this to be interactive. So if you have any opinions, please do jump up at the mic.
And actually, the more I thought about this recently, the softer my opinions became, or squishier they became. Right, so no slides, and I apologize for that, but only a little bit. Last August there was a workshop on advanced cryptography standardization, and Riyad Wabi, I don't know if he's here or not, gave a talk. Need to stand closer? Okay. Riyad Wabi gave a very good talk on work being done in the CFRG, and it was definitely worth listening to if you're curious about how to write crypto algorithm specifications. But anyway, he was sort of confused about what the CFRG does in relationship to standards and what the IRTF does in relation to standards. And he's someone who is active at it. So when thinking about it, I think that the way IRTF research groups are increasingly functioning is blurring the lines between the IRTF and the IETF. The way that meetings happen and the way that documents are handled are signaling that what's going on in IRTF research groups is actually standards related and that it is IETF related. So I took a look at 7418. Thank you, Spencer. It's a great document. But it was written 5 years ago, and it was raising some of the same questions. I mean, section 2, which is the bulk of the document, so it was like the IRTF is not the IETF, and talked about some of these issues around how meetings are conducted, how documents are progressed, and so on. And so I think that as research groups are meeting more often with the IETF, we're adopting more and more of the IETF mechanisms, and some of these things do include things like the use of internet drafts as documents rather than research papers, the use of consensus-based decision-making, the notion that we want to agree on something rather than necessarily supporting a diversity of opinions. So basically, the question is, as this increasingly happens, my feeling is that we need to accept things as they happen, but I also think that we need to be careful to preserve what we care about in the IRTF, the research orientation, and continue our focus on producing sort of ideas and enlightenment rather than specifications and engineering. This is showing up in research group proposed charters as well, in particular, and this is an area that I think could use a lot more focus. So that's basically it. As Colin said, this is an opportunity for discussion and sharing opinions and trying to figure out how we want to go forward and whether or not there's anything that needs to change.
Okay, thank you. Does anyone have anything to raise? Oh, good. Dirk.
Hi, I'm Dirk Kutscher. Yeah, so in general, I fully agree. So we have to be careful not to develop a certain, ossified model of doing our research here in the IRTF. And also, when we talk about what makes a IRTF research group successful, or what is a good relationship, and so on. Of course, it's nice if we can, move some work to the IETF at some point. On the other hand, it's going down. On the other hand, it's also valuable output if we, are able to invalidate certain assumptions and, for example, are able to say, okay, this actually doesn't make sense for the internet, and maybe we export it, but enough is enough, and let's move on.
Yes, fully agree. We don't have to produce something which can go further. We could, we can explore something and then say, yeah, we've done it.
Hi, Brian Trammell. I was looking at the list of, or the big, all of the research groups we have now, and it's cool that we're almost all meeting, and I think Dinergy was also scheduled and then ended up getting descheduled, so we almost had all of the meeting here. And one of the things that struck me about the scopes of those is that they don't really overlap, but there are a lot of places where, there's kind of gray areas maybe between Coin and some of the stuff that might come out of Panergy eventually, and between Coin and Dinergy, and, all of these in T2T, and part of, they're all kind of looking at the same sort of problem space, which is what's next for the internet with an internet focus, but from different perspectives. That would not work at all in the IETF, right? Like having two working groups working on exactly the same thing is an excellent way to annoy the IESG. I hear a couple of ex-area directors laughing. The idea of the IRTF is sort of a lab for the IETF. I think you actually do see it in the set of research groups that we have right now. I really like Dirk's suggestion, right? Like, so or actually I'm really jet lagged. One of the two of you just said this about like, hey, we have to be a little bit bolder about allowing things to fail, right? Like, so, or like, let's spin it up and let's have a look at it. And the idea that the success is something's going to come out of this, it's going to go into standardization, shouldn't be the goal. And maybe I'm just saying that because I'm a co-chair of Panergy, which has like a very, very, very long time scale for anything that might ever come out of that and be standards, right? So yeah, I think the let's keep throwing things at the wall and see what sticks model works pretty well. I think we've done a pretty good job of avoiding an anti-pattern that may have shown up in the past that was, a research group is your consolation prize for a failed BOF. I think continuing to push back on that anti-pattern is a good, and I also say that as a co-chair of Panergy. I think pushing back on that anti-pattern is a good one to continue doing. So yeah, I think we're actually doing a pretty reasonable job here.
Laurent Chavalia. I think this is a very important question for the IRTF and IETF to discuss. Maybe we can also consider not necessarily already the stage where there is a research group being proposed, but more there is a research question or a research topic and how and where it could be addressed. I mean, maybe IRTF and IETF have some ways of seeing the world or approach problems, but they may be also wider scope. If we think ITUT, HC, other groups, or even, other organizations, not necessarily standards related, may also be other opportunities to the stage or the life cycle of a research idea or research proposal can go through different groups and be matured at some stage and then maybe be brought up to the IETF and maybe go somewhere else. So I will consider very important IETF, IETF, but maybe also try to widen a bit the scope because there may be other groups or stakeholders that could have good views or good competency in progressing a research idea in the overall ecosystem.
Yeah, I mean, certainly a lot of the research groups have historically had pretty close links to academic conferences in the area. And I guess the network management group would be one of them, but it's certainly not the only one. The quantum internet group, I think, has reasonably close interactions with some of the conferences in that space too.
Hi, Stephen Farrell. So I think I think there's lots of good aspects of the IRTF being close to the IETF. One of the less good aspects, I think, is that research group chairs find it hard to deal with a lack of consensus. In the IETF, we're looking for rough consensus. That doesn't need to be the case in research groups, but I think more and more, it seems like there's a tendency to try and, reach the same bar of rough consensus. Whereas I think research groups would sometimes be better publishing something that's, whether it's a draft or an RFC or something, but this is this person's opinion. Lots of other people don't agree with it, but it's still an opinion. I think it would be good if research groups were more encouraged to allow that kind of lack of consensus.
Yes, I think that's a very good point. You do not need research group consensus to publish an RFC. You need to have an interesting document which the group thinks is worth publishing, and the IRSG agrees. And as long as it's clear that this is an opinion piece rather than a consensus piece, that's just fine.
Yeah, I think maybe it needs a bit more encouragement.
Yeah. Equally, research groups are not evaluated based on the number of RFCs they produce.
Tall people.
One tall person.
One tall person. Right. Wow, now I forgot what I was going to say. I did forget what I was going to say. You go ahead.
Jana Iyengar. So I want to second what Stephen said. I think it's valuable for IRTF research groups to recognize that the processes of the IETF might be convenient because they're familiar, but they're not necessary. And we certainly shouldn't stick to them as though they are required. I've just been considering how to, as chair of ICCRG, I've been trying to figure out how to publish documents in ICCRG and what it means for us to publish documents. And I've been in conversation with CFRG chairs and other folks and trying to understand that. At the end of several long conversations, the conclusion I came to was, doesn't fucking matter. You do what you do and you publish something useful. And ultimately, whether it gets used or not is a function of a large number of things. But our goal in ICCRG is to publish documents that are interesting, that might be relevant. And it's not so much to try and come up with one right answer for various things. So I want to just take a moment to say that it's very useful, I think, for the IRTF to be associated with the IETF because it gives relevance, it gives a space where we can understand problems from a practical point of view, from what matters to the standards point of view. At the same time, I think it's also useful for the IRTF to be slightly independent of the IETF and to think of itself as independent from the IETF. It doesn't need to be driven by IETF. It doesn't need to be driven by things that will go back into the IETF or problems that are necessarily coming out of the IETF. So it occupies an interesting space. And in that, I will just say one last thing, which is it provides a venue. It's not just the work that's happening in the research groups. I see increasingly ICCRG as a venue, as a community, where we are able to bring people in from academia, from the industry, from standards areas. I have people who come only for ICCRG from the industry, and they also happen to be in the IETF. But that's what I want to foster. I want to have that community be built and the community to be available so that when we actually have problems in the IETF that needs this community, we have the community available on hand.
I remembered what I was going to say. We've talked about the IRTF not being a forum for sort of advanced engineering within the IETF context. But there does seem to be demand for that activity to take place somewhere. The IETF working groups are very, very narrowly scoped. They have very specific deliverables, but often people want to talk about engineering problems more broadly. And because there is not any place for that within the IETF, I think that tends to push that into the IRTF a bit. And it's really not within the IRTF purview to deal with that, but it is something that I think we might want to be talking about with the IETF.
Yeah, I think that's an important point. The IRTF works, the IETF working groups are very narrowly scoped. The IRTF is very blue sky, and we've had a couple of discussions with there's a gap in the middle, and several people have mentioned this.
Dejan Bogdanovic, I wanted to say the same thing, and we can take an example of the Network Management Research Group and the NetMod NetConf. Where one is very detailed, down to the bits and pieces, and the other one is very blue sky, and sometimes challenging some of the thinking about in a new framework, new architecture, how to do things that are being done in the IETF. Getting such feedback from the IRTF would be useful, and trying to say, hey guys, stop working on something that is being 20 years as a general accepted concept. Try to think in these new terms, and getting some of those new thoughts from the IRTF would be helpful.
Yes. I suspect the scheduling could be made to work if people want joint sessions to have these discussions.
Hi, this is Eve Schuler from Intel. So I like this discussion a lot. So thank you for bringing it up. It points out to me, at least, that in some ways, this discussion around relationships with the IETF is around what's our metric for success in the IRTF. And maybe one of the predominant ones is, informing the IETF. But it also raises the question, what are these other ones? And some of the relationships that are spawning now among some of these other groups, if you look at the research group Thing to Thing, it has to do with sort of the broader community and many of the relationships with other standards bodies. And so it just got me thinking about metrics of success and best known methods and things like that. And I wonder if collectively as a research community within the IETF, we can catalog some of those and sort of share some of those in terms of like what are our objectives as a community, and then ultimately help the IETF more. So just thinking out loud. And recognizing that there are more metrics to success beyond simply the relationship with the IETF. Yes.
I think that is certainly true. And a research group is not necessarily expected to produce anything which would be useful to the IETF. It's there to understand the problem space. It's there to explore some ideas. Produce some new knowledge, and occasionally that leads the group to a place where another effort can be spun up in the IETF to then standardize something based on that outcome. But that's not necessarily the metric for success, although it's a metric for success. And just understanding a problem better, producing a bunch of papers, producing a bunch of PhDs, is a perfectly reasonable, successful outcome for a research group. Yes. So I think the points I would like to highlight, as a research group, don't feel that you have to follow the IETF process. Don't feel you have to have consensus. It's often convenient to meet here, and there's good reasons to meet co-located with the IETF, because it gets some nice discussions and interactions with the standards community and with the people building products. But meet in other places. Meet with conferences. Have workshops. Do whatever helps advance your research. I'm sure Alison will remember that some years ago, I seem to remember the Reliable Multicast group meeting on the beach in Cannes. next to the SIGCOMM conference. So we can meet in all sorts of places. It doesn't just have to be in a windowless meeting room next to an IETF meeting.
Tim Buckenberg, I think actually that's a very interesting remark, because this also promotes the IETF in those other places. So we talked a lot about how the IRTF maybe can contribute to the IETF, but let's not forget that there's also another way around, so that there's that this is an opportunity to maybe get new people interested in what we are doing within the IETF as well. So thank you for the remark.
Yes, it's a way of fostering discussion between the industrial side and the very academic side. I think that's a very nice role the IRTF can play. Okay. All right, next up is it Aaron or Laurent? Or? Who's doing that? What we load, they kind of work.
There we go. There's not that much on the slide. Now the other side. There we go. Okay.
Okay, we got most of the slide up.
Yeah, and some. Okay. Hi, I'm Aaron Falk. Whoops, slide's gone. I can't talk without the notes. So before Colin was IRTF chair, and before Allison was IRTF chair, and before Lars was IRTF chair, for about 6 years I was IRTF chair. And Colin asked me to and Laurent to work together to prompt some discussion on examples of IRTF-IETF collaboration. And so this is mostly one person's opinion. Maybe folks will disagree with some of these. But I think there's a lot of different models that are represented on this slide of things that I think work well, and some things I think are anti-patterns, and some which might or might not be good patterns. Some of, probably more, some cases I'm unsure, in some cases I just don't know enough. But so let me just walk through a few of these, and maybe folks can add to them or come up with some other examples. I think that the more that we can share best practices of how IRTF-IETF collaboration works well, the better it's going to be. And you'll notice the arrows don't always point in one direction. So I think a good recent example is the ICC NRG, the congestion control. I think I have an extra letter. The congestion control research group. I got it wrong, but the congestion control research group has performed a valuable role in vetting congestion control proposals. There was a time when people would bring their research project in congestion control to the IETF and ask us to put it into TCP, which has a number of fallacies in it. One of which the IETF doesn't standardize congestion control, or at least it didn't then. I guess it's more down there now. But also that there wasn't really there's a lot of questions in terms of how things are going to work in the real world before you start to take a position as to whether it's something that you want to roll out into the internet. And so this research group was created, and one of the valuable functions that they did was to bring together researchers who are familiar with congestion control and research in that area to evaluate proposals and then make some recommendations as to whether IETF protocol should support it. A different example is in the delayed tolerant networking folks. This was a fairly large research project, multi-institution research project, who wanted to see the protocols become standardized, but there are a bunch of open issues. And so a research group was created to come up with, to kind of sort through what the research community had done and implemented. And out of that came some proposals for standardization, and a working group was spun up to standardize that. So that was, I guess that's a little bit more of a one-way arrow. I guess maybe Stephen, were there things that came out of the IETF working group that fed back into the research group? No. Okay, so that was a one-way arrow. Great. Network management research group. I guess Laurent can comment to this. Was the proposals through there became part of the ANIMA working group in the IETF. CFRG, I think we've already talked about a little bit, that it brings together a bunch of folks from the crypto community who aren't naturally participants in the IETF process, who evaluate cryptographic proposals and make some recommendations that the IETF can then use to evaluate protocols. And so I guess the way that I understand the security area works is there's sort of a deference to the CFRG to give like a thumbs up or thumbs down on crypto proposals. And so that's sort of you bringing in an area of expertise that isn't really present in the IETF, but the IETF relies on quality in that area. And so that's sort of a little bit like the congestion control idea.
There seems to be a couple of groups where there's a bunch of expertise in the research community which develop interesting ideas, whether that's congestion control or crypto, and demonstrate that they work, and then the IETF groups say, yeah, that's useful to us. And,
so I think it's maybe a little more nuanced than that. That in some cases they're coming up with ideas. I think in this case, like CFRG, is they're evaluating proposals that come from outside. So if you so there's a vetting process that requires expertise that isn't present in the IETF.
Yeah, there's if I remember right, they seem to run a bunch of competitions for, we want an algorithm to do this, and some proposals come in and they evaluate them and figure out which ones work.
Yeah. So, reliable multicast is a fairly old or long-lived activity in the IETF, and I think that's an example of research that turned into some standardization. Didn't solve all the problems, but there's some protocol work that came out of it. The peer-to-peer research group was kind of had a whole burst of energy. I think that came out of some issues in industry, and then the research group was trying to come up with metrics for evaluating aspects of peer-to-peer protocols, and then the Alto working group came out of that. So I think these are different kinds of success. Let me go to the anti-patterns, and then I'll come back to the uncertain ones, and maybe that'll be the start of some discussions. So the name servers research group was kind of winding down when I came into the IRTF, but for a long time I had heard like that next generation DNS is happening in this research group, and the research group was closed and never actually published anything. And so I think that's an example of where nothing came into the IETF, and so that wasn't a very effective way of collaboration. That's like we said in the last session, that's not always the objective of a research group, but I think there was a bunch of proposals that went into the IETF and then were redirected into this research group, and then nothing came back. So I think that probably was a little bit of a swing and a miss for the organization. Anti-spam research group. I think that there were hopes that there would be proposals for how to deal with spam that came out of this group. I think that very little IETF activity actually took off from that. I'm happy to be corrected from that. I'm looking at Stephen. I don't know. All right, so not you. Uncertain. HIP was, I think, an interesting IETF activity. There was a bunch of energy in the hallways to implement HIP. HIP was proposed as an alternative architecture for addressing a bunch of problems at the time in the IETF, and they tried a few BOFs to get work going in the IETF. I think that was, my opinion is it was proposed as a little bit too sweeping in terms of what they were trying to accomplish. And for that reason, it sort of bounced off that, we charter working groups if we think that they're focused and they're going to, have narrow goals and accomplish those goals in a reasonable amount of time. And so then they became a research group. And I think that there's been some HIP implementation, but I don't think it had the deployment that they had hoped for. Do you want to comment now, Allison, or wait?
Yeah, I'd like it if you define uncertain, because you're starting uncertain with HIP, saying it didn't really succeed. And when you and I had a little exchange about this in email, I'm Allison Mencken, it was, you said it didn't really mean that. So
Well, so my feeling is that this is that this characterization is I'm uncertain about. To me, it is not obviously a good example or a bad example of IRTF IETF collaboration, and so I think it's a little bit of a mixed bag. So I feel like HIP I don't think is a clear example of like it working really well, but it is an example of something that was sort of, there was stuff happening in the IETF and in the IRTF, so there was some collaboration. So I'm uncertain as to whether I would call it a good example or necessarily something that we should, an anti-pattern. So that's...
Okay, I'm going to stay at the mic
okay,
for when
great.
you continue.
So the routing research group is, this is when I came into the IRTF, the routing research group had been around for a long time. And I think that it was not a good example of collaboration in that what I saw of it was that proposals that the IETF didn't want to deal with were redirected to the routing research group, oftentimes that they would just not come to the IETF. The end-to-end research group, and I think is, so I put this in the worked well column based on your comments, and I think that Colin didn't get my updated slides. So let me speak as if it was in the worked well column, because your comment, I was persuaded by your earlier comment, Allison, that it was an example of a bunch of research activity that found its way into the IETF in, I think, it was a much longer lived research activity, and so it was less not the same kind of example of something that was focused like DTN, but something where there was a lot of research that happened over time. It was a closed research group, and so it was kind of indirect in how things came out of the research group and into the IETF. There were a few examples of drafts, but there were also research papers and implementation projects that came in. And so it's a very different animal than some of the other stuff in the left-hand column, but I do think it's a good example of the collaboration. And then the QIRG...
It was a very open-ended activity, as I understand
it. Measured in decades, yes.
Popped out, yeah.
And so QIRG I put in here because it's new, it's uncertain, but I think that it's I don't want to say yet that it is a great example of IRTF, IETF collaboration, because there's really been very little IETF activity, except for the fact that there was a QIRG tutorial, which was very popular. And so if you want to look for a different kind of pattern of IETF, IRTF collaboration, a sort of an education approach, of like, here's an interesting research area that is related to networking and may have eventually activities in the IETF, but in the near term is a source of information and educating and sort of raising the clue level in IETF participants. Then I think QIRG is sort of an interesting example of that. So at this point, the
one thing I would want to add is end-to-end. It really did. It was a task force before, and it was a peer of the IETF. So it was a different animal indeed when it first started out, and for like 20 years. But to be clear to people who might not know, it incubated our entire media, the internet media protocols. It incubated DiffServ. It incubated ECN, all kinds of stuff that we wouldn't have without it. So what kind of thing could be like that in future? I'm not sure, maybe nothing, but it was actually very high impact on the IETF, just quite different from the research groups we have now.
Yep.
Hi, Stu Card. I have to kind of agree with your characterization of HIP in terms of a burst of promising activity and then a long dormant period. But I would like to say that the rumor of HIP's death is greatly exaggerated. And I think the reason that it may not have been a poster child for IRTF, IETF transition is that perhaps it transitioned a little early before there was a clear application pull for the technology. But the trustworthy multipath remote identification BOF tomorrow morning is an application pull for which we think HIP is actually an excellent fit.
HIP in our time. Very exciting. Christian.
Christian Wittemer. Yeah, Aaron, at the time, there were some research groups that were closed membership and some that were open. Did you observe any kind of relation between the fact that something was closed and its success or not?
Well, two of the groups on here, the only two that I know of, closed groups are on this list. So the name servers research group, NSRG, I can't remember if name servers is the correct expansion, but the names research group was closed. And then also end-to-end research group was closed.
Yeah.
And so I think we've got both sort of a positive and a negative example. So I don't think we can draw conclusions. Also, this is pretty far back. I don't think that there have been any closed research groups in recent memory. Everybody's shaking their head. So But I think, Christian, you raised a point that I wanted to make earlier on in the discussion in the last section, which is there's an enormous. The IETF has a very constrained process because we want to be open, transparent, and standards organization. The IRTF has none of that, and there's a lot of flexibility in how research groups can operate, and that discretion is typically given to the research group chair to organize it in a way that keeps the energy up and accomplishes stuff, and so. Making a group closed is one aspect of that, but meeting in other locations is another piece of that. And I don't know if it's still the case, but it was for a while. The only requirement was that you should meet once a year at an IETF meeting to promote some collaboration and cross-fertilization of ideas. But other than that, you can pretty much do what you want. I think that's a great thing.
David?
Yeah. So I was going to comment on a couple of things. First, end-to-end as a closed research group is going to leave people with the wrong impression. It was closed in that membership and participation was by invitation only, but the chairs were incredibly clueful in figuring out who to invite and reach out to and move forward. So that was quite a bit of. The other thing I was going to do, I think, is probably mostly on your next slide. So you're going to get to that, or do you want to talk about?
I wasn't actually going to prevent the next slide. That was more sort of reflection on stuff, and I thought that the discussion, the reflection from the folks in the room was probably more interesting than, than that. But if you want to go to the next slide, we can.
Well, having got a glimpse of your next slide, I think the different forms of transfer is really insightful because the first bullet there basically is an incubation. It's pre-standards, and the goal is to spawn standards activity. And a group that started that way needs to have the courage to say, we've done the job, we're getting out of business. The second line is an area of overlapping expertise. Where for both ICCRG and CFRG, you can identify a community of expertise strongly grounded in research that is complementary to the standards work that we do here. And that's a really good structure because it avoids inflicting the research on the protocol development and the protocol development practicalities on the researchers.
Laurent should get credit for making most of this slide, since it's so insightful. And I agree with your comments.
Wes Herdeker, ISI. One other good thing that came out of it, and when you're totally done, I have a much longer thought train to expound upon for both the previous presentation and this one. But the NMRG was also actually the root for NetConf and Yang, and it was a short-term model that has certainly heavily affected the IETF today. And it started as sort of a fairly short project of 2 to 3 years. That it was too long to do in the IETF, and the research, was the right place for it to start. And then it's certainly transformed a lot since then, but it's a great tech transition story.
Thanks, Wes. I wasn't involved in that, so it's helpful to know. Spencer.
Please finish your slide.
I don't feel the need to say anything else.
Oh, okay.
Hi, this is Dave Oran. You focused on a bunch of things in the IRTF that have had, for better or worse, interesting characteristics in their interaction with the IETF. There are a few of things here where we also want to look at our failure models as well as our success models. And I can think of at least a few research groups, which I will not name, that wound up getting chartered, and then we discovered that there actually weren't any interesting research problems. and they bounced around for a while, and they couldn't produce a standard because they weren't in the IETF, and yet we discovered that what was happening in those research groups wasn't research. So one of the things I think we do need to sort of guard against is allowing groups to keep going on and on and on with not understanding what the boundary is, and there actually aren't any interesting research problems in that domain that could drive a research agenda. So just a word of caution there.
So I guess my first response to your comments is that that's
none of the
that's
ones on your list
for the
fall in that
discussion. For
category.
this is about IRTF IETF collaboration. But to respond to the substance of that,
some of the groups which will go unnamed, in fact, were chartered because there were things that were believed to be needed in the research community that weren't ready for the IETF to deal with. And that kind of collaboration with the thought that things might transition into the IETF were motivations for forming those groups. So let me just reiterate my point. There have to be interesting research problems independent of whether the output is something that winds up in the IETF or not.
I think that this to some extent is the difference between research and development. That we need to find interesting research problems, not just interesting advanced development problems.
Well, maybe you and I disagree on this, but I think that there's room in the IRTF for both if there's an energized community that wants to work on it. Because again, my personal opinion is that the IETF succeeds with things that are pretty well defined. And there are things that are not very researchy that may need more definition. I think having them happen in the IRTF is okay, but that's different from, so I think that there's a lot of different kinds of things that can grow in the IRTF. And I think that I don't see a benefit to creating another organization to hold those things because sometimes it takes people with, it's that research and implementation collaboration that the sort of joint expertise that it takes to sort of get them over the line so that they can be baked here. So I don't disagree with Dave. They don't always succeed. I mean, there's the list of concluded research groups for some value of concluded is much longer than the list of active ones.
Of course. I think we need to be clear that there is that we believe there are research issues before we charter a group. And
you're the boss.
Yeah. My view tends to be that if it's just that it could be engineering, it's just a longer term focus than a typical IETF group. To me, that should be perhaps a different type of IETF activity.
I don't want to get into semantics on where you draw the line between research and engineering, but I think it's hard to come up with an objective measure on what that is.
There's always a bunch of things in a gray area.
Yeah. But ultimately, the judgment on whether it's in or not is yours. That's what comes. Somebody at the microphone say something.
Yeah. So Spencer Dawkins, and I wanted to thank Colin for putting this topic forward and Aaron for doing this presentation. I wanted to cut down to your bottom bullet about documenting this topic more precisely. It seems like to me that one of the things when we succeed in research groups, at least some of the time, we do that by involving a lot of people that don't understand the IETF very well. And that means that it makes transition hard, especially if they don't know what's been tried before and what has been tried that has worked out badly. Back in the day, not very long after Lars became IRTF chair, he had me working on what became, I think it's RC 7418. That's the IRTF primer for IETF participants. And the problem we were shooting at back then was people coming from the IETF with the understanding of the IETF process, and that's not the way the IRTF works. And the thing, I don't know, it's like 8 or 10 pages long. something like that. It's not very long, but it has the list about, scope and timeframes and, participation and meeting places and stuff like that. But that was the problem that we were dealing with. That was the problem the chair of the IRTF was dealing with then. And it seems like to me that because we don't have the same research groups now, and we don't have the same IETF, and we don't have the same IRTF chair, it seems like the problems that the IRTF chair is facing now is more getting things slotted in the right place in the first, on the first bounce, so that it's not the fail-off consolation prize that people tried to make it. And how, just documenting what the models are. DTNRG basically kind of picked up stakes and moved to the IETF. That's a model. Other people have models like ICCRG, which is a completely different model. I would caution against trying to make this very precise, because the research groups are really, the scopes are big, whether the research groups are big or not, and they're really different, and we don't have a lot of them to base criteria on. But to just even write down, what happened in the past and how it turned out, which is oddly the PAN-RG draft on what not to do, is kind of doing for path-aware networking, but to basically do the same kind of thing for the IRTF and the IETF interaction.
Yes.
Wes?
I think that's important.
Wes Herdeker.
How are we doing on time?
We've got a couple of minutes, so
Okay.
If we close the lines after these
Okay.
comments.
Did you say 10 minutes?
There's another talk.
A couple of minutes. We've got another talk.
Okay. All right. I can go on for 10 minutes. So, I think looking at both the last two talks, right, they're very informative. And how do we think about the IRTF over the longer term, and especially working groups and when they're successful? And there's a real challenge there, because there's a width issue, right? IRTF groups need to span from, far-reaching research that, is looking out in far distant future to stuff that needs to transition, fairly quickly. And actually specifically transition to application and real interoperability. And so, you can look at results as, we measured this really cool thing. We found out that nothing needs to change. That's still a success, right? We've looked at a problem space and we found that there is a problem. We're creating new work or a new working group out of it. That's great. And we have improvements and suggestions, and that got transferred into protocol changes, on the wire. So that's the easy thing. But the thing is the success possibilities for a research group are so wide that it might actually be easier to look at what do we not want. And so I have a couple of examples of that, of which, research groups that fail might include research groups that produce no documents. I think you had an example of that. Research groups that looked at a problem space, found a solvable problem, but failed to find an audience, right? Where it just sort of fell on deaf ears, and then that would be a problem. And similarly, deaf ears when you discover protocol deficiencies in existing stuff based on research that failed to actually transition to fixes. And like actually the winner presentation from today is a good example of that, of trying to figure out how can we get that fixed? And if it doesn't get fixed, that's to some extent a failure.
Yeah, I would say the most insidious example of something that doesn't belong in the IRTF is a particular company proposal that is trying to create something that looks like an open forum but doesn't have a constituency. I saw several examples of that when I was IRTF chair, and I think that was it's like, okay, maybe there's interesting work here, but it's just like your little narrow thing. There's nobody who wants to collaborate with you, so we're not going to create a group for you, no matter how many people you have show up. So, but I think your examples are good as well. Eric?
Eric Nordmark. So listening to you guys debating on stage sort of the boundary between research and advanced development, I mean, I think that there is this other space where what does the IETF do versus the IRTF when there's some new work coming in, and people sort of have some vague notion that there might be something here, but the proponents don't seem to be able to describe it very well. Or sort of, is it because they don't understand the problem space, the solution space, the constituents, but it's rather vague, right? And those things get tossed around. And sometimes might depend on IRTF chairs. Some of it might have landed in the IRTF. Other times the AEDs have worked with these people sometimes for many IETF meetings to try to sort of distill something out of it. Sometimes the IAB or an IAB member gets appointed as a shepherd to try to help them, and maybe it leads to a BOF or something. But that's one of the challenging spaces where we believe that we want to be open and invite this new work, but it's not necessarily that well formed. And I'm not arguing that should land in the IRTF. It's just that we collectively should sort of figure out a way of handling that, right, as opposed to it being bounced around. But
I think that's an excellent point. Do you have a proposal?
No.
Do we have time for Rich?
Last one.
Last one.
Rich,
all right, so I just want to mention on the bottom two sub bullets. I think it's always good to write things down, but you want to be careful to make sure that it doesn't become a requirement that all research must successfully transfer. And the learnings, I think, if written from the ICFRG side, from the research side versus the IETF side, they might be very different, which would also be interesting.
Yeah, it's a good point. I should have added a column on my chart that was no transfer, and it was still a great thing because there's a bunch of research groups, especially that are active now, that fall into that category. Okay, thank you, everybody.
So thank you, Aaron. And yes, to be clear, there is absolutely no requirement that anything transitions in standardization. We as a research group, the idea is to develop some ideas, some technology. A group of people may look at the outcome of a research group and say, this is appropriate for standardizing. They may not. And it's a success either way, as long as we learn something. All right, so having spent some time talking about how the IRTF and the IETF can interact, we'll talk a little bit about how the IRTF and the broader academia can interact.
Hi, it's me again. And for the people who started hearing me at 7:15 this morning, I promise it's the last time. So this started, I mentioned when I did the COIN presentation that we had two interims, and this discussion actually started at our last interim in October, and we figured out that it was a topic that was much bigger than a research group. It was something that was for the whole IRTF. So I would like to thank everybody and the COIN community. Jana talked about communities. Well, that's one of them, and especially Lars, who sent us a set of very interesting slides, and actually I borrowed one. So that were the comments. Academics do not do drafts. Good point. Attendance from professors and students is often very difficult for questions of budgets, and because we seem to be the roaming conference here, and it's true, it costs money. We need to do a better job of connecting academia and IRTF. I agree. The other inputs, one of them was from Colin, was that, well, there's more than drafts. The drafts is the IETF way of moving forward, but maybe there's something else. And maybe the typical draft format is ill-suited for research discussions, and also the typical draft presentation format. At a lot of IRTF meeting, we would like to know the progress of the research or the new ideas in research, not just the delta from the last version of the draft. So we decided that, okay, let's get some thoughts around this, and let's look also what happened in the past. And I promised someone I was going to discuss this, but a few years ago, I was on an HDR evaluation in France for somebody who had an impeccable a way of applying for this. I didn't even know how we could say that this person was not going to get this. And then one of the reviewers said, but look at his publication record, he's got 8 RFCs, but not a lot of publications. And my first thing was that he's got, wow, that's amazing. And that if you think of the usual people who read a conference paper, there's 3. Think of how many people read a draft before it becomes an RFC. And the amount of comments that you get from all kinds of people, from all kinds of sources. And, I thought it was amazing, but it was actually highlighting a fact that in academia, people do not really understand what a draft and what an RFC is. So the top concerns was, again, that these draft and standardization in general, but we're IRTF, we don't do a standardization, but that drafts are poorly considered in academic circles. Well, probably because people don't know what they are. The other point was that we needed to have more dissemination of the research group activities. A lot of people don't know we exist, or have they know maybe one research group exists, but they don't see how it fits, with this whole ecosystem of internet research. And there were the travel and the participation aspects. Well, I'll go back actually, because the first thing that I think was very easy to resolve even on the call was the travel, because, more and more there's people who are participating remotely to this. And if it's not for the 13 hours ahead or the 16 hours ahead or waking up at 2 a.m. to attend a meeting, you can participate remotely and that won't cost you anything. So that for me was moat. The other ones were much more important. So writing a draft is not necessary to participate in the RG meeting. We don't put if you don't have a draft, you don't come in. It's not the case. We've had a number of academic presentations, and I know a lot of other research groups have had that. I think the networking prizes and the workshops are exactly the right type of example of research that was done somewhere else that is actually now brought to this community. And we really welcome grad student and postdoc. And again, I mentioned in our presentation that we participate in the hackathon, and I will be honest with you, when we participated in the hackathon in Montreal, was actually to have a lot of the local grad students being able to come and see how it was going as a whole, because in the hackathon you have all the groups are there, and it was actually to enhance this participation from the local universities. And another thing is, again, I mentioned this draft perception, kind of uneven, but if you think about it, mindsets are hard to change. And some suggestions were that maybe we should state better the research challenges. I think a lot of times on our wikis, on the GitHub, and even on the charter, we're very, very focused on something we would like the group to achieve, but maybe not how it fits in the greater world of the research challenges for this field. We could invite participation of people. Actually, I thanked Dave last time in Montreal. He had suggested a researcher in Chicago who had a fantastic presentation and was essentially had been invited for this. Co-locate, actually people mentioned this, and co-locate interim meetings or even meetings during a conference that are related to the field, and organize workshop. And there's actually a great presentation from Lars on bridging the gap between internet standardization and networking that he presented in Brazil. Other ideas. Maybe create and then share specific use cases and data on the wiki and basically create leverage, not just for one research group, but maybe link to what other research groups are also doing so that people can start navigating through it. Add some research group topics in academic seminars and presentation. I will try that. We're doing ICN 2020 in Montreal, and we want to add some presentations, some seminars, some workshops that go across a number of things and see how we can actually disseminate not just one research group, ICN, but maybe also the other one I'm involved with, COIN, and network coding. And maybe we always say you can actually take your research and bring it into a draft. Well, why don't do the other way around? Also take some of the draft examples or the draft presentations or the draft writings and bring them into a paper. And Aaron has a question.
Aaron Falk.
Hi.
Lots of good stuff here, Marie-José.
It's nice to meet you outside Cambridge. That was 5,000 miles away.
One idea that I've seen that is not on here is something the NMRG implemented, which is that they did pre-publication reviews of papers, and I think they needed some confidentiality to be able to do that. But there was my understanding is that folks perceived that as being a real benefit, and the papers improved.
Good idea.
Are you finished or?
No. There's 3 more slides, and maybe my question will be, your question will be
I'll
answered.
wait.
But, please ask your question. If it's further, I'm going to say yes.
Well, I don't want to prevent you finishing. So, quick anecdote, right? I actually was told recently in a year that I had 0 academic papers and a couple of RFCs that, that wasn't good enough. And so I totally get that, that particular issue. And then this year, I actually have 2 really good academic papers and 0 RFCs because the RFCs are taking that much longer and that much harder to get through the system. And I'm now going on like working group last call number 3 because people really care. And so you're absolutely right. I think one of the fundamental problems, though, is no matter how much of these other things you do, the IETF and the IRTF are not listed on the academic, grading scale of conferences from A to F. And
I think
how
it's uneven.
valuable they are.
I think it's uneven. I think in some circles it is well known, in others it's not. And I think it's our goal to make it maybe bridge that gap.
Yeah, I want to actually other comment because in my case, my supervisors absolutely know what the IETF is since ISI actually helped create it. So, the knowledge of not understanding it isn't a problem. It's just from the academic, grading perspective.
Yeah.
I think it's interesting the way different countries evaluate the research. In some places, research impact is very heavily assessed, and the IETF, IRTF activities count for a lot more than in other regions.
Alison Mankin, I'm inspired by your bullet about vision or blue sky papers, and it struck me from some of my past time, like at NSF, that fields have like 10-year horizon planning that they do a little bit formally, but that is very valuable for those fields in terms of getting funding. And maybe that's another way you could do this is have kind of informal review here in RGs free, but lending itself to that kind of consensus about what big open directions are that could be helpful for the community, the academic community.
Okay, thank you.
Dejan Bogdanovic. So I'm looking at the second, idea, invite participation in research groups and ideas from leading academics. Let's say I'm a regular IETF participant contributor. How can I know who are the leading, participants? Usually how we know people come and volunteer. This is who we find out who is interested in the area that, that we are doing some work.
Yeah, but I think, okay.
It's a chicken and an egg problem.
Well, I think I'll sound like a social media guru here or some kind of influencer, but we all are at the center of, especially in this research world, we're all at the center of a large number of connections, and we know who are the leaders in our group, in our world, and we can actually reach out to them. And if they cannot come because, for a reason they can't, a lot of times people are really nice and they're going to suggest somebody else. So I think we should not think that the world is limited to this room. The world is all around and connected in 100 ways. So I actually strongly believe that, if we invite, every time I've invited somebody in this environment, even when they couldn't come, they actually suggested someone else. You wrote that line at the bottom, Eve. So.
Oh, about the Vision and Blue Sky papers.
Yeah,
yes,
that was yours.
It's because I keep seeing that conferences increasingly are including Vision and Blue Sky papers, and they are often invited papers. So, it's in some ways like a free pass into a conference, and it's super fun. But I wanted to go back to the point about how do we get the academic community to change their perception that the RFCs aren't as or more important? At least we want equal grounding, right? Or we want people to be rewarded for it. And I wondered whether in the same way that Vision and Blue Sky papers are around fostering, looking further ahead, and that's what the IRTF does, whether we can reach out to some of the communities and I'm from the US, so this is a US-centric idea, but it translates to other geos. If we go to places, we have organizations like the NSF and like DARPA, and the Army has some lab. There are structures in place about what are the organizations, particularly government funded, that are looking at the challenges of connectivity and so forth, and having a seat at that table. And that's where the academics see that we have a seat at the table. And
I think, I think there is an example of how this it works. I'm old enough to have come to the IETF where it was really only US people. And I'm also a reviewer on the European research projects, the big, well, now it's called H2020, but it was called all kinds of other things before. And at one point, somebody put in some of the outcomes and dissemination was participation in the internet, IETF. And suddenly the rise of Europeans in the IETF went that way. And I think maybe there's some similar thing that we could do in the IRTF to get more participation and dissemination.
My point was that we can certainly go out and ask others to come into our community. How do we go out and get invitations?
Well, I think it's a two-way thing.
Right. So that was more the nature of my point and question.
Christian Wittemer, about the RFC and evaluation. The RFC editor pushed a change in the RFC format a couple of years ago. I don't know whether you noticed, to have an OID reference on every RFC, which was precisely to facilitate citations of RFCs in journals. And you can actually very easily count the citations of a given RFC on various libraries. And I think that if we are concerned with that, then you can use these citations as a way to give weight to publications.
Yeah, thank you.
Markku Kojo, an additional note related to this. There is a very good paper published in ACM-CCR by Brian Carpenter and Greg Partridge that discusses the role of the RFCs as a scholar paper, starting from how to cite them.
Thank you. Okay, so I'm getting out of... Oh, hi, Dirk. I'm sorry.
Dirk Kutscher, just quickly, I'm thinking that this presentation and also the discussion is suffering a little bit from what we actually criticized earlier. So projecting known methods of working from the IETF to IRTF research, and then wondering, oh, why doesn't this work for academics? So I think you even mentioned standardization on an earlier slide. I mean, this is really not what this is about. And so RFCs, I mean, that's an issue that, so we know that a standard strike RFC takes some time, but that's not what we're doing in the IRTF. And so I think what Dave mentioned earlier, that's really important, that so there are at least two criteria to be aware of. So say some useful output for the IETF in some way, but also, I mean, doing really good, relevant quality research. And if we are not able to do that, no academic will find it interesting to come to us. So, and for that, I think it could be interesting to discuss, say, certain indicators or say models that seem to work well, and also maybe ask the question, I mean, what's the point
of writing a draft or RFC. I mean, there must be some, some utility to that. And so what I think is really useful is see this as a means to enable experimentation. So to be able to, take the, academic research, ivory tower things, and keep people honest and make things comparable, and then try to gain some insights out of that. And this is where our model is useful. So writing up specs in a sense and looking at that. And so I would kind of maybe turn this around and maybe ask what are good indicators and say good models that have worked well.
Thank you.
Jana Iyengar, I'll be quick. I agree that drafts have a use, but you point out that hierarchy of draft perception in the academic world is uneven at best. I would argue that any draft perception in all worlds is uneven at best. Just to, not to belabor the point, but even IETF drafts are all over the place. You can have an independent submission, you can have an informational RFC, you can have RFCs that have had review that haven't had as much review as we believe, and the IRTF is completely, it's much more, there's much more variance in IRTF drafts than there is in the IETF drafts. And in that sense, as an academic who's gotten tenure based on publications, I couldn't rely on RFCs, and that's just a fact of life. It's not. I don't think it's reasonable to expect academics for us to change the perception, because it's not a perception issue.
Yeah,
it's a real issue in the sense that the goals of what we do here tend to be different than the goals of what academic publications tend to be.
And my question to you is, why is that the case? Because we want to foster good research. If you look at the papers that are always presented out of the networking prizes and everything, it's always top-notch stuff. So it makes no, we're not doing second-rate stuff here. And I think that's actually part of the perception.
So maybe, so the second point I was going to make might speak to what you're just asking. I want to disagree with the fact that we do research in the research groups. I'll disagree with this personally. I think we foster research.
Well,
I think that's an important distinction.
It's fine, yes.
I think that's a very important distinction. And the distinction here is
but our participants do research.
Well, so I'll give you an example, right? In ICCRG, I think we foster research. What that means is there are groups that go off, do research, publish, come here and present what they've done.
Yep.
And they'll keep coming back and doing stuff. They don't use us as a publication venue. We as a research group aren't publishing one thing, but we are engaging with various entities, various groups, students, industry groups that are publishing on their own, but we are creating an environment where they all come, talk, and we have a forum for that to happen. So as a research group, I think we foster research. I don't think we are a publication venue, but I think we should be clear about the fact that we are allowing and encouraging and making the research happen, but the metrics shouldn't be publication.
Hi, Dave. I want to go beyond and emphasize, I think, even more strongly what Jana was getting at. I mean, I do research. I run an RG. I participate in RG. If I have some super great idea, I'm not going to take it to an RG. I'm going to write a paper and I'm going to get it through a double-blind program committee and convince people that this is super novel and something that's going to change the world. What RGs are, I think, going to be most successful doing is this collaboration function, right? Which is because academics, I got to tell you, they don't collaborate very well with each other. They're forced to by their funding agencies, and if they weren't forced to, they wouldn't do it. So Eve's here, and she may want to comment on this. We have a really good joint project between NSF and Intel that talks about wireless edge computing and ICN. Yep. I think we have a absolutely perfect zero record of getting anybody who was doing research under that project to come and present it at either ICNRG or any of the wireless oriented research groups. And the reason for that is that it's extra work for no particular benefit in those contexts. So for me, I think we have to push this collaboration and community aspect of the function of the IRTF, and make our case based on that, as opposed to we're doing great research in the IRTF. Thanks.
Yeah, and I think, I was always thinking was that it's not that we do good research. I think our partners good research. So thank you for correcting this. Yes, Eve.
Yeah, out of time, I'm afraid, Eve.
Oh, okay. Okay, so I switched a few things. I skipped a few things, so I can see that obviously we can do better. I really like the idea of the fostering. I really like the idea of the communities. And actually, I'm going to conclude with something that I said this morning with my first presentation at 7:30. What we want to create in this agora for people to come and share and, essentially have the rest of the community understand what they're doing, why they're doing it, and how we can create even more research. Thank you.
All right, thank you very much. Thank you again to Wei Tang for the ANRP presentation. Thank you to everybody who spoke later. I think that's been a really interesting discussion. Hopefully we can continue this discussion throughout the rest of the week. Thank you, everybody. And if you have the blue sheets, please pass them to the front.